Hello and welcome. In this video I will talk about generating a spiral matrix, okay? And I will try to show you how to think about these kind of problems, and I want it to be easy to understand. So I did not perform any tests about performance issues, right? Like I said before, it was designed to be readable and easy to understand and not for performance. Okay, our first problem is creating a matrix of 5 by 4 that starts at the bottom left and decrease the number, and it follows this pattern. Okay, and this is our goal. At the beginning this can be very hard, so let's see this problem in a simple way. We can see the matrix as if it has layers like this. We have one layer and we have a second layer, and if the matrix was bigger we would have more layers, right? So this suggests us that we have something that is repeating, because we can navigate in this layer and then we can navigate in these layers. Okay, so if we go to the code, I have these rows number 5 and columns 4. I have an array of arrays with rows and columns. Also, I already have this method print matrix that prints a matrix. Okay, just have this to add a 0 for numbers below 10. Okay, what more? Like I suggested here in the slide, we have something repeating. So in the code we can say that we have a while true, because we know nothing about the cycle. Okay, so let's go. Now what to do in each cycle? We don't know, right? Well, we have to navigate in the X position first, and then navigate in Y position, and after in the X again, and in the Y position again. We have here two concepts. The first one is the coordinates X and Y, okay, and the second one is how many positions each coordinate will travel. Okay, in this case are 3, in this case are 4, and 3 and 4. Okay, so two concepts, X and Y, and the number of steps for X and the number of steps for Y. So going into the code, we can declare the first concept is X is equals to 0, and we are starting at this position in the 20, so the Y will be something like rows minus 1. Okay, this is our first concept, the coordinates, and the second concept, how many steps for the X will be the number of columns minus 1, hint X steps is equals to columns minus 1, and for the Y is something similar, but instead of columns we have rows, the number of rows minus 1. So going into code we say Y steps equals rows minus 1. Okay, we have here the first thing to do, and if you see this, we have inner cycles, one cycle for the first X, and the second cycle for the Y, and the third cycle for X again, and the fourth cycle for int step is equals to 0, and while step is less than X steps, because we are moving the X coordinate, we will increase the number of the step. And now we can access the matrix at Y and X and update the X. Okay, this position we are increasing the X because we are moving from the left to the right. Okay, this is equals to what? We need an integer, a number that is equals, this is the 20, so it is the number of total elements in the matrix, so rows multiplied by columns. And we say that the number at this position is equals to the number minus minus to update the number for the next position. Okay, next we will move in the y, but we are decreasing the y, right? So let me copy this because it is very similar, but instead of x we have y steps, and instead of increasing the x we are decreasing the y. For the third and fourth loop we have something similar, okay, but is the reverse for each case. So copy and paste. So here we are increasing, here we will decrease, and here we are decreasing, here we will increase. Is simple like that. Well, we have this true, okay, we have to remove because it will run forever, and we will change by while number of steps is higher than 0 or y steps is higher than 0, something like that. And if we run these, something should or should not happen. Sorry, we have to update something. For the next cycle, for the next layer, we must update the x steps and the y steps, right? The x steps will have less two columns, and the y steps will have less two rows, right? So if we go here, and after all these 4 loops, we will say that x steps is equals to x steps minus 2, and y steps is equals to y steps minus 2. And also in the last for loop, the x and y coordinates will be pointing to this house again, okay? And we want to move to this one. We must decrease the y and increase the x, because the x move to here and the y move to here, so the 6th position. We say that x is plus plus and y is minus minus, okay? So if we run, now we have this, and we have our spiral matrix. It works. If we try for 4, works, for 3 works, and 3 4. Let's try 3 4. It works, and 4 4. It works too, okay? But if we run for 2 5, okay, let's try it, 2 and 5, and if we run, something is wrong with these guys, okay? So let's try to understand what is going wrong here. So we have 2 5, and we have these this is the expected result, right? So we start with x step with 4 and y step with 1, this, then we will update. We will say that the x steps and y steps are equals to these values, minus 2, okay? The cycle ends, and we update the values. X steps will be 2 and y steps will be minus 1, sorry. So what will happen, it will update the position, okay, and it will start again the cycle. Because y steps is minus 1, this 4 and this 4 will not run, okay, because x steps is less than 0. Y steps, sorry, is less than 0, okay, but the x steps will run because it's 2 and steps is 0, so it will run at least 2 times, okay? So each case, this one and this one. So going back, these values will be compromised, okay? And let's try, instead of or, we will use and. Okay, so here and if we run, now our result is correct. Okay, but if we try 3 by 5, let's see, 3 by 5, 3 by 5. So looking at the slides, well, we have this problem. Why? Because we have this scenario. We have x step equals to 2 and y step equals to -1. Okay, so since y step is less than 0, the while loop will stop, and this case will be ignored. Okay, and we can take advantage of knowing how many positions we already have reached. Okay, so we can have a new concept. The concept is the keeping track of how many places we were. Okay, so to do that, we call it like int visited, okay, and it is equals to 0 at the beginning, and we must know how many elements are there, so the total will be the number of rows multiplied by the number of columns. And now we can say here in the while loop, while visited is less than total, we will run the loop. Okay, then we must update here the number of visited, okay, plus visited, and we must do it in every loop, the second, the third loop, and the fourth loop. Okay, also we need to check this on the loop and this on the loop, on every loop. Okay, so like this. And now if we run the code, I expect that it is going well. Okay, so now this is working and we are happy, right? The next challenge, 3 by 3. Let's see, 3 by 3. Run, and nothing happens. Actually, we have a index out of bound exception. Let's see what's happening. Well, first we run here, and then here, and then here, and then here, and x steps is equals to 0, y steps is equals to 0. Okay, so it means that this for loop will not run, and these two, because y steps is 0, 0, so these loops are not running, so we are not affecting these and we are not updating these. Okay, so it will stay, it will one house is left. Okay, so this is a special case, okay, where visited is equals to total -1. And now we have to add another check, and this is a special scenario, so we can say here, if visited is equals to total -1, we must do something different. We must say that the matrix at the position y -1, because y was updated, and x plus 1 because the same reason, is equals to the number. Okay, and I insist to write this wrong, and then we break the cycle because we don't need to do it anymore. Okay, and let's run this, and now it's running and is cool. Okay, let's try 9 by 9. Okay, it's running and it's cool. Well, like I said before, this is a special scenario where we have a odd n by n matrix with odd number, where n is a odd number. Okay, so it works again, and Thanks for watching and hope you like it.